In this video, I'd like to look at a HTML page with an SVG element that uses JavaScript to create a design sort of inspired by Victor Vasarely's Boglar. Uh, Sorry if I'm mispronouncing that. Um, so it has some sort of checkerboard pattern, and in uh, some of the squares there are circles, and then in other of the squares there are smaller squares. And so that's the sort of general motivation here. And then here is the page that I have created here. And what I have in my checkerboard pattern is that the squares turn into circles and back into squares. So if you pick a particular square, right now it looks like what's inside of it is a square, but then as it evolves, it's changing color, but also the interior shape changes to I have two colors, and right now those two colors are pretty close. Now they're getting different enough to see. So I'm pointing at one square here, and we see that the interior shape sort of goes from sort of something very squarish to something very circle-like and sort of oscillating back and forth. Okay, so here we go. So HTML page, some style, some centering, some style variable giving me the half of the size. So my image there was 600 by 600. So this half size is giving me, as it says, half of that size. And then here's me styling the SVG using var and calc to be twice that size. Okay, and then I have a border around the SVG, and that's mainly so then I can see where, what as I'm working, I can see where the SVG is easily enough. Okay. Um, so I start the HTML, the body of the HTML. There's my header, there's my empty SVG, and everything else is script. Okay. So I am going to work with creating sub-elements of the SVG. And so I am going out to this sort of expanded namespace here. Now I thought that I should just update this, and I tried to update this by just adding an S to this website address, and that proved to sort of bring the whole thing down. So that's clearly not right. So the number is the number of cells. That's not what I wanted to show you. The number of cells sort of going across. And I have a timer. And so I usually, when I start a timer, assign a timer ID. That's mainly so I can turn the timer off, and I don't turn the timer off, but I'm just used to always sort of establishing a timer ID. H1 and H2, I'm working my color scheme. You saw that I was changing the color. This is, I'm working in a hue, saturation, lightness color scheme or color model. And I have two colors. We saw two colors. And so H1 and H2 are these colors. Okay. I have a timer, and I have things that are time dependent. And so I have a time parameter. W, I don't remember what W is. I'm not even sure I use it. Okay. P is sort of the inner shape, sort of like how much I'm coming down, say, from the top for the inner shape. So so I come down from the top, and I also come up from the bottom. So the sort of diameter or width or what have you of the inner shape is 1 minus 2p. And Q is a variable I'm going to use. I'm going to make my interior shape that's changing shape with cubic Bezier paths, and Q is going to be a parameter in those cubic Bezier paths. So for right now, I just set it equal to 0. It's not going to be 0, but I'm just here initializing it. The K is also has to do with the Bezier curves, and it's just this I probably should have said constant here. This is a number, it's sort of, I want one of the shapes we're going back and forth, and one of the shapes is more like a circle. And so a sort of standard question is, how can you use Bezier? I'm going to be using Bezier cubic curves to approximate a circle, and this parameter K comes in there. So there's a Stack Overflow reference there that says that if you're sort of doing it going around the circle sort of a quarter at a time, then and you want to approximate a circle as much as possible, then this sort of number comes up with what are called the controls. Okay. I set up my size in the style, and this is me getting that value of the half size here in JavaScript. And then so 2 times this M is the width of my SVG, and then I'm dividing it by num, so that becomes the size of my cell. So A is the size of my cell. Here, I'm using set interval to establish a repeating timer. That timer is going to call the function Boglar every 33 milliseconds. Okay. And then here is the function. So I am going to the element on the page with an ID of SVG Boglar, which was the only thing on the page, pretty much just the SVG, and clearing it out. I am incrementing my timer, and I am moving the H1 and the H2. I change the amount. So the sort of distance between the colors is not fixed. And so you saw at one point I was talking and the 2 colors were quite similar. So that's because they are changing at different rates. So there are times when the difference can be small, and sort of like one of the hues sort of passes through the other one. I have this checkerboard pattern, so I'm creating that in this case with nested loops. So I have a loop over I's and a loop over J's. Okay, here I'm using the HSL, the hue-saturation-lightness model. So there's a method, HSL, and I am working with here H1 and H2 along with my I and J. So I have I plus J modulus 2, divide by 2, take the remainder. So that's going to be a 0 or a 1. And so I'm flipping back and forth in my checkerboard pattern between H1 and H2. So we saw that. That's the change of H1 and H2. Going back and forth, I'm working at 80% saturation, and then I am varying depending on the distance from I to num divided by 2, sort of. So num divided by 2 is the sort of center, and I'm changing the lightness as I move away from the center. So we could also see that it's darker on these edges. Okay, and then I have another color where instead of I plus J, I put I plus J plus 1. And so that is, that's my other color, but the I plus J and the I J plus 1 gives me, again, this is part of that checkerboard pattern here. Okay. So one of the main patterns is just a bunch of squares, which are rectangles. So I'm creating an element NS. Well, a rectangle, I'm putting it at the x is I times A, the y is J times A, the width is A, the height is A. I'm coloring it, filling it in with color 1, and I'm appending it. So that is my checkerboard pattern of squares. Okay. Now here is this Q, and this is this parameter that is going to play a role in Bezier. And so it involves, I have a cosine function. It's changing with time. So we see that, of course, it's almost the same colors again, so it's hard to see, but it is changing with time. And it's also is a function of this I plus J. So this Q parameter changes from in the checkerboard pattern. So that means on sort of in one set, I'll say it's a bipartite lattice, and so on one set of cells we have the circular shape, and the other one we have the square shape, and this is sort of gives me that sort of alternating pattern, this I plus J modulus 2, because I'm multiplying that by math of pi. So that's putting me in the sort of the opposite phase. They're completely out of phase with one each other in terms of cosine. Okay, so 1 minus 2p, that is the diameter of the inner shape. The maximum that a cosine is going to vary between +1 and -1. So when it's -1, we have 3 minus 1, which is 2 divided by 4. That's a half. And I'm multiplying that by the diameter, so that's the radius. So when I'm at my smallest, when Q is at its smallest, I am K times the radius, and that is what I was told was the circular shape from the Stack Overflow reference. And then at the other extreme, when the cosine is +1, then I'm 3 plus 1 is 4. So then I'm going to be like 4 divided by 4, K times the diameter. And so that is that more squared off shape. So the higher this Q, the more square-like it is. So I'm varying from going back and forth with my cosine as depending on the time and also depending on the modulus of I plus J, the mod 2. I am going back and forth between sort of K times R and K times the radius and K times the diameter. K times the radius is the more circular shape. K times the diameter is the longer squared off shape. Okay. Now I have to tell you a little bit about Bezier. So I'm going to do the Bezier in sort of go around the circle in 4 quarters. So I have already established a square shape, and that was sort of I times A, J times A, I plus 1 times A, J, A, I, A, J plus 1, A, and I plus 1, A, and J plus 1, A. So that's the square, and I've shown it here in light blue. Then when you do a cubic Bezier, you have a point where you start and a point where you end, and 2, I'm going to say, control points. So I'm going to start, I want to make this shape that is at the half. I'm starting at the top of the shape, or I'm just going to imagine it's the circle for now. I'm going to start at the top of the circle. So that is halfway. Here was IA, here was I plus 1A. So I'm starting at I plus 1/2 A. And then vertically, I'm coming down this little amount, P. P was the percentage than I was from the top. So that has nothing. The Q comes in with the controls. So that's just my anchor point, my starting anchor point for this quarter of a curve, um, uh, quarter of a circle, I'll say. Uh, I am ending at a one I plus one minus p. So I'm on the left edge and I'm coming back p. So my x value here is one plus I minus p times a. And in terms of j, I'm halfway down. So j plus a half times a. So those are my two anchor points. And so when I make a Bezier curve, these points I actually hit, I actually go to. And then there are two intermediate points that you don't go through, but they are your control points. And that's where this Q comes in. And so I I add to my horizontal here a Q. So that makes this blue dot, and I'm drawing this yellow dotted line. And then over here, uh, I work for the second control point. I am subtracting Q from my vertical. And so what these control things do in a Bezier curve is that you uh, come out from this point. So first you have the anchor point, which you must go through, and then you leave the anchor point going along a vector determined by this other point. So it's coming out horizontally. And then the final point, the anchor point, you actually go to that point, and then you approach that point as if you were coming from uh, the second anchor point. So that's the idea of a cubic Bezier. And so, and then the value of the Q determines whether you are, how long you sort of hang along this. So that special value of K times the radius was the value for a circle. But if this is longer, then you stay along this yellow line for longer. You don't ever hit these anchor points, but you stay along that parallel for longer if the line is longer. And that gave you that more squared off shape if this Q was larger. So that's my explanation of Bezier curve. And then so there's this starting point, and then this control one, control two, and the final anchor. And then what we're going to do is if you keep going, then this point now becomes your starting point, and you have two more controls and the anchor. And so what am I making here? I played with this Q. I am making a property called the D. There's a property D of a SVG path. And so my D is, as I'm making, I was call it my D, my this, my that. So I'm calling it my D. And the syntax is first you start with an M, and that is the point where you start. And that's where, in my picture, that's where I just said I was starting. I plus a half and J plus P. So so I introduce that as M, and that is my starting anchor point. And then from there, they have a bunch of notations depending on whether you're doing quadratic Bezier or cubic Bezier. I'm doing a cubic Bezier, so I'm using a C. A quadratic Bezier only has one anchor. You use the same anchor for both sides, but a cubic Bezier has two of these. Sorry, not anchors, but controls. The cubic Bezier has two controls, two anchors and two controls. The quadratic only has two anchors and one control. Okay, but I'm doing the cubic, so hence the next thing comes in with a C to announce in its cubic. And it also comes, I'm going to use the one that has, I'm going to use a capital C. And so I'm going to work with sort of absolute points, absolute within the SVG, rather than if I used a small c, then these would all be differences from my starting point. So I'm going to work. So these are, full points rather than changes from what I had above. If I were working with changes, you can see that I would only change this X by Q, and I wouldn't change the P. I wouldn't be changing horizontally at all. So might have been simpler to work with the small c, but I'm sort of translating this from one language to another, and the other language used the sort of full points. So I'm not taking advantage of everything I can in the sort of what JavaScript has available, that JavaScript and SVG have to offer here. Here's my second adding. So I say C, I have my first control, my X and Y separated by a space, and then a comma, and then my second X and Y, my second control, and then my third point is the anchor. So that got me from here to here. And then it is assumed that that last anchor point becomes the next one if I carry on. So I don't need another M, I just carry on with C's. And so I carry on with the C to do the sort of, this part of the curve, then that part of the curve, then that part of the curve. So I need sort of 3 more of these Bezier vertices, sort of control, anchor. So control, anchor, control, anchor, control, anchor, and I'm all the way around. And just to be absolutely clear, there is a notation where you add a Z at the end, and that says you're making a closed path. Now, I had it set up that my last anchor was my original starting point. So I sort of ended up myself closing the path, but there is a notation for closing the path. If so I just sort of made doubly sure that it knew it was, in case there was some rounding or something funny along the way, I wanted it to know it was closed, so I added the Z. Okay. So that was this Bezier. I create an element NS, making a path element. Its main property is this D, which is all this above. There was one more simpler notation simplification that I didn't use. So I didn't use the small c, I used the capital C. Might have been smaller if I used the small c. And there's another simplification that you can use where you work with an S rather than a C for these continuation points. The first one is you have to have all 3 parts. But if as you move on, if the first control of this continuation point is sort of a reflection of the previous control, you can work with an S notation where that would be understood. So if I were working with an S, I probably could eliminate, I'm not eliminating the control point, but I'm eliminating the need to express the control point. So I didn't do this as simply as I could have. So there we go. So, but this paths are hard to work with. But once I'm sort of establishing the properties, this D property is pretty complicated, but it's just one property. And then I didn't have any outline. I didn't have any stroke. I just have a fill. And then I add it to my SVG. So there we go. We have the design. We have the rounded shapes turning into squares and vice versa, and the colors changing. And so that was my design, SVG design made in JavaScript and inspired by Victor Vasarely's Boglar. Right, that's it. Thanks for your attention.